So, how do we go about making our AI monstrosity? First of all, our Frankenstein AI is built using a mix of MATLAB and C and lives on a nearby computer system. I used MATLAB because Project Momentum is a very real thing and I am super lazy. I use C because it turns out getting real-time responses out of MATLAB is really hard. To get information into the AI, we can just use a simple USB capture card. These things are slow and they're cheap, but they look basically like a webcam to the computer, so it's very convenient to work with. Getting information out of the AI is a lot more work. And this part, please don't do at home because you might damage your console or yourself or your home, all bad things. I basically did this by taking a replacement NES controller, and then I soldered it up to an Arduino. The AI then sends a command to the Arduino, which shorts out a couple of the buttons on the NES controller board for a fraction of a frame on command. I had to build a whole bunch of code to do this part. This plan was disrupted a bunch when I realized that A, my simple USB capture card was a piece of crap and didn't conform to any of those webcam standards that MATLAB was expecting, and B, that I don't actually have the toolboxes necessary to talk to serial devices with MATLAB, so I went ahead and I built a bunch of local servers coded in Python and connected these up to my MATLAB code. So, super straightforward, right? Next up, let's talk about that super sophisticated AI we're going to use. Short story, we're not. You don't need deep reinforcement learning to beat me at Tetris. You just don't. I'm not that good. I'm exploring these approaches for more difficult games, but for this video, we're just going to choose our moves based on a greedy strategy where we train with an absurd number of games. Let's take a quick look at the greedy strategy we're using. So first, we calculate every possible final position a piece could end up. These are all the possible moves that the AI has to choose from. Next, for every final position, we assign a score, and then identify the position with the minimum score, which is our best possible move. And then finally, we convert that final position into a specific set of controller inputs for the Arduino to make use of. Sounds easy, right? Well, the devil's in the details. Just what kind of bullshit was I pulling when I said assign a score to a move? I glossed over that a bit, didn't I? Let's look at an actual example. Let's say that we have a 2x2 Tetris piece that we want to place onto this board. You could imagine placing it so that it partially completes the top two lines. Or alternatively, we could place it so that we don't bury a bunch of squares on the first two rows. It gets more complicated as well, because we actually don't just consider the current piece, we actually look one piece in the future and pick the best movement given the next piece. So, to build our score function, all we're going to do is take all of these metrics, the number of isolated tiles, number of partially completed lines, and so forth, and we're going to combine them together as a linear function with some parameter weights that tell the AI how much it should care about each of these things. Finally, we need to discuss the cost function for the AI. So when I say the AI should care, what do I actually mean? How is it making its decisions from a practical outside perspective? For this, we keep things very simple, and we just calculate the average number of pieces placed by the AI before it dies. We can then iteratively search for higher and higher numbers of pieces placed by tuning these parameters, so the AI is trying to live as long as possible.